Good morning, everybody. I'm going to talk this morning about a new idea that's just launched as of last Friday called a Global Deal for Nature, and offer some guiding principles, milestones, and targets. And what the Global Deal for Nature is a science-based, time-bound plan to save the diversity and abundance of life on Earth. One of the ways of depicting it is right here in front of you by one of our co-authors, Dr. Greg Astner. This is northern Borneo as you've never seen it before. Here are oil palm plantations, which you've seen, in a monolithic color. But then here is the glorious rainforest, one of the richest on Earth. We're essentially using a technique called imaging spectroscopy. Every different colored tree here represents a different genus or even sometimes species of tree. So you can not only see the kaleidoscope of colors in the natural forest and the monotypic color here of the plantations, but also the massive amounts more carbon that are stored in here, which will figure into this talk. So quickly recap history of life on Earth for refresher for everybody in about 20 seconds. So life on Earth has existed for roughly higher life of 550 million years. In the course of that time, we've had 5 major extinction events in the history of the planet. The most recent was 65 million years ago when a meandering asteroid happened to wander into the coast of the Yucatan that took out the dinosaurs, led to the age of mammals, and by accident, why we're here today. And so the 6th extinction has happened in really the last 200 years starting, where this is the only one where humans have been around for that extinction event. But we're seeing background rates of extinction rates 1,000 times higher than the background rate. And because of this extinction spasm or crisis or tsunami, a number of scientists have called for the most logical step that's science-based to avoid the 6th extinction crisis was to essentially save half of the Earth in the marine and the terrestrial to preserve biodiversity for future generations. The first stirrings of this idea for a global deal to protect half the Earth came from a paper that we published in 2017 that only focused on the terrestrial realm in terms of what needs to be protected, and then further with a blog post that we've now formalized in a paper that was just released on Friday in Science Advances. And in this talk, I'll explain the key elements of the Global Deal for Nature, how it interweaves with climate science, the most recent climate science, and how we can use this to try and create this plan to save life on Earth. I suppose some of this is going to be new to you. Some of it hopefully will inspire you. Some of it will motivate you. Some of it will infuriate you. But hopefully it will all mobilize all of us to try to address the crisis, the two crises, the two great existential threats of our time, which is climate breakdown and the species extinction crisis. So this is the new climate science that underpins the work that we're doing. Now, for a long time, we all love to operate in silos as scientists and seldom break out of them. And that's been true for biodiversity science and climate science. But this recent climate science that just emerged at the end of 2018 really cements the idea of how climate change, addressing climate change and addressing the species crisis are intertwined, and you can't do one without the other. So that's really the key take-home message of my whole talk. So let's try and walk through this new graph that explains the climate science behind the biodiversity science. So many of you know that in late fall of this year, the 2018 Special Report on Global Warming of 1.5 degrees C is an effort to figure out how do we stay below 1.5 degrees. And this is the first model that offers a pathway to do that with just an aggressive conservation program and a rapid transition to renewables without having to resort to great expansion of nuclear power, advanced nuclear, geoengineering, or any kind of carbon capture, that it can all be done with natural solutions. So this is essentially a probability of to stay below 1.5 degrees. Al Gore called his work an inconvenient truth, and I think that was a misnomer. It's more the devastating truth that we're finding now of what happens to Earth's natural systems if we go above 1.5. And the answer is more and more that a lot of systems, from coral reefs to tundra, these biological systems start unraveling, which have tremendous feedback effects. So let's walk through this really quickly. Here's 2018. Conveniently, we have land sinks and ocean sinks that absorb about half of all the greenhouse gases that are emitted every year. This is the annual accumulation of gigatons of carbon dioxide, and that's the cumulative. So right now, our natural systems are functioning really well to absorb about half of this. A fraction of the greenhouse gases are coming from land use change. But we see that around 2030, this starts to decline, that these become saturated and are no longer able to absorb greenhouse gases. So what we have to have is this transition to renewables that hopefully reach zero fossil fuel emissions by 2050. But to do that, we have to secure all of the land that is available, which is about 49% of the terrestrial realm is still intact or semi-intact, plus or minus 1 or 2% there. We're also going to need some efforts at restoration. So those of you who are restoration ecologists have a major role to play here in fostering this, that can suck out about 400 gigatons of carbon dioxide. That will be essential because we know that there are still going to be emissions post-2030, even though that's where we need to see a moratorium on emissions from land. So clearly, the take-home message from this is that the rapid energy transition is needed, and then to spare all the land that remains from further emissions by 2030 to make this model work and stay below 1.5. And the probability of that is 50% if we can stay below 392 gigatons of carbon, and that increases as we continue to move down this cumulative curve of anthropogenic emissions. So again, that if we want to stay below 1.5, that we need all of the remaining habitat in some form of management to reduce emissions, and that goes a long way to addressing the species extinction crisis. And if we want to save biodiversity, we need 50% to stay under. So the Global Deal for Nature has 3 main themes. I'm just going to focus mostly on protecting biodiversity and mitigating climate change. Reducing major threats could be the subject of an entire symposium, so I really won't touch on that. One of the other co-authors of our paper, Dr. Reid Noss, is, I consider, the father of modern-day conservation biology, came up with 4 of the 5 sort of underlying principles of conservation biology, that what we're trying to achieve is representation, all habitat types in some form of protected area, saving species, maintaining ecological services, and then addressing environmental change to maintain evolutionary processes. This number 4 has been added recently to maximize carbon sequestration. So those are the goals that conservation biologists try and achieve in any kind of large-scale conservation plan. The antecedents to this idea of saving half of nature go way back, long before Ed Wilson came out with his book, Half Earth. Eugene and Howard Odum came up with protecting half, and notice here, to ensure maintenance of ecosystem services for people. Reid Noss came up with a strategy for conserving one of the more densely populated states in the United States, Florida, where 50% was in conservation. And the map of Florida today looks remarkably like this, with the Everglades down here and networks of corridors protecting reserves throughout. Bob Pressey in Systematic Conservation Planning found that reviewing a lot of ecoregion or conservation plans, about 50% was needed. Noss and Harvey Locke and our own group at World Wildlife Fund spent many years doing conservation plans and found similar things, that somewhere between 25% and 75% is needed to achieve those 5 goals, settling on about 50%. But it's an empirical question. Depending on the ecoregion, that's what determines how much is needed. The scientific guidance for this, are many of you familiar with the term ecoregions, ecosystems of regional extent? First came out in 2001, updated in 2017. For those who haven't seen it, a paper that came out late of the end of last year, a global test of ecoregions by a group at Stanford, did the first independent test of the validity of ecoregions by using gazillions of GBIF records of plants, animals, and fungi, testing those against ecoregion boundaries, and found sharp discontinuities as you move from one ecoregion to the next, validating the use of these 846 ecoregions as a framework for conservation planning. So let's take the first analysis of what could the world look like if we're moving towards this goal of 30% protected by 2030, which has been advocated by a lot of groups. And the answer is that there's very hopeful messages here. There's 219 ecoregions that already have 30% protected. There's actually 100 ecoregions or more that have 50% protected. If you add up the numbers of ecoregions that are either at 30% that could get there just by better protection, or that require a little restoration, which is the orange, 2/3 of all the world's ecoregions could reach 30% by 2030. Now, the downside of this is that 192 ecoregions that we call nature imperiled, that on average have only about 4% of protected area in the entire ecoregion and 1% that's outside. So this is where the extinction crisis is going to be most swift and severe, where immediate action is needed. By biome, we can see that tundra and boreal, almost all of the ecoregions of the 14 biomes, these two biomes could reach 30% easily, and tropical rainforests, whereas the breadbaskets, the centers of food production, are the only really biome that cannot. This idea of 30% by 2030, so I'm going to quickly summarize this. There's just two main points here. Here's 50% for intensive human development on the terrestrial side, and then here's the 15% that's already protected. If we need another, say, 15% or more by 2030, it can break down this way. The key messages here really are, there are a lot of different approaches that have been taken over the years for setting priorities, and the fact is, if you sum these units here from hotspots to Alliance for Zero Extinction sites, they only account for a small sliver or fraction of the area that would be needed to protect rare and endemic species that would fit in here, just because there's so much spatial overlap in those approaches or those paradigms. This idea of climate stabilization areas we'll come back to in a second, but this component here could be achieved by 2030, as could this one, which we'll get to in a second. Are there any marine ecologists in here? I'm going to skip this one then. Enrique Sala, one of our cousins, would kill me. Just to say that marine has a much longer way to go, an enormous hill to climb with not as much protected. But remember that in marine reserves, the diversity is an order of magnitude higher of fish species, and the biomass is 6 times higher inside protected areas than outside. So this spillover effect that can occur is vital for marine fisheries and why we need to protect marine resources. I'm going to just go now to mitigating climate change, the second major theme. This is a map that you might not have seen before, produced in part by Alessandro Bacchini from Woods Hole, one of our co-authors. And what it shows is not just above-ground carbon, but total carbon. So above and below, the darker the green, the more total carbon. And so you can see here how tundra and boreal, which are often neglected in terms of global priorities, emerge as vitally important to maintain the safe operating space for our planet. But also, it's overlaid here with the world's intact large mammal assemblages, such as this caribou here. They're also home to some of the largest aggregations of large mammals on Earth. So a clear conservation target. Now, this idea of climate stabilization areas, if we need to get to 50% spared, or 49% by 2030, one of the comments that came out of the symposium or the breakout group yesterday is, well, I'm for 50%. We took a vote on this, but not the way you typically do conservation. Okay, so climate stabilization areas are, simply put, they're areas of where the natural vegetative cover is conserved and greenhouse gas emissions are prevented. That can take any form of management that people can come up with, or whatever individual countries think is appropriate. But it's essential for conserving areas like the Amazon, which is about 37 ecoregions, but almost all of them need to have at least 85% of contiguous forest cover to continue operating as one of the weather machines for the planet, where the rainfall gets recycled 10 times before it hits the Andes, flows back to Africa or up north, and helps influence crop production. So having these under climate stabilization is really important. Now, let me see a sign of hands here. How many of you affirm the sovereign rights of indigenous groups to management of their lands? Raise your hands. It's not a trick question. So how many don't? probably embarrassed to do. Okay, so everybody does. Okay, so that's a given. So that's a fundamental aspect of the global deal for nature, is that, you know, you almost never see indigenous communities represented in scientific meetings, for example, and their voices aren't heard, and their voices aren't in the scientific literature. But from their own traditional knowledge, setting aside half has been consistent through many, many cultures. And so some of the leaders of this global deal for nature movement are directly from indigenous communities who see this as consistent with their own view of the earth. And so here's another important fact to remember, is that when you say, oh, it's going to be impossible to conserve 30% or 50%, 37% of all the remaining habitat in the terrestrial realm is under indigenous claims. Whether that's titled or it's claimed, it depends on the area. But 37% is already there, and that 37% conserves 297 gigatons of carbon dioxide, of carbon. So we don't want to release that, and simply empowering communities to have access or ownership and sovereignty of those areas goes a long way towards this. I'm not going to get into major threats, just that fishing is the major hunting operation on the planet. We have problems in invasive species, roads that can circle the Earth 600 times, infrastructure that's being planned for the next few years, as well as toxics and plastics. And the global deal for nature includes features, milestones, and targets for all of these to be comprehensive. But protecting land isn't enough. So in the 15 minutes or so, 17 minutes since I've been speaking, one elephant has been killed in Africa by poachers. So it's 4 every hour, 35,000 a year. At this rate, forest elephants in the Congo Basin will be extinct in 10 years. So for certain species, intensive protection and recovery is also part of the global deal for nature. There are other ecosystems that provide important services, for mangroves and coral reefs. Anywhere between 0.5 billion to 2 billion people derive their protein from this. If coral reefs bleach out, then this source of protein eventually evaporates, and they'll have to go to land to find that animal protein, complicating things even further. One of the greatest areas for innovation is in agriculture. Now, there are some papers out now, the new Lancet Eat study, that shows that we could feed the world on 50% of the land that remains. Other studies show that we could actually feed the world 10 billion people right now if we just addressed distribution issues and food waste. But this is an area where tremendous research and innovation can play a major role into finding this harmony. And then also those of us who are involved in monitoring the health of the Earth, from using advanced spectronomics to monitor getting these in satellites, to getting if you can imagine, we're not far away from a new vegetation map of the Earth every 18 days if we can get spectrometers into space, to ground sensors like the one I have here in my pocket that I've been involved in called TrailGuard, which is this one here. That's a camera and computer the size of my index finger that can not only run deep neural networks that identify tigers, but can also identify poachers as well, and does the information on the edge, the processing, and sends that for near real-time alerts. So we're entering a whole new era of conservation and management. That's very exciting. So the cost of this is about $100 billion per year. Everybody's got their favorite comparison. Mine in the United States is that we spend $33 billion a year on pet food and grooming. We love our 2 dogs at home, but I'd gladly equal that contribution if I knew that was going to help conserve life on Earth. If Greta Thunberg was here, she'd be saying, please join us, and she's hopefully going to be contacted and joining the Global Deal for Nature. This is where we go from being scientists to also being activists and to mobilize. You can go to this website and sign the Global Deal for Nature. We're generating about 50,000 signatures a day. This is a petition we're developing through Leonardo DiCaprio Foundation, National Geographic, and Avaz, the world's leading campaign organization, with the idea of generating 30 million signatures to present to the CBD before 2020. We don't have hope that world leaders are going to embrace the Global Deal for Nature without a gentle push or a swift kick in some part of the anatomy to move faster, given the timetable that we have. And so that's why this is critical to move forward. And hopefully that many of you represent different groups will join I see many of the locals here, and many of the indigenous communities that are represented in a lot of fora have already signed on to this. So thank you very much for your attention, and hopefully this has been inspiring, if not infuriating, but motivating. Thank you.